from the lecture instructor. So lisod kayo lahi may og kanang exercises o lahi-lahi may number of exercises. So muna nga, usan na lang namo, and I think Sir JC will just give you grades for final project para ma-equalize na mo ang point system. So the topic for this afternoon is basically on spatial referencing and measurements. And unsa may pasabot ana nga content, oh wait, nabali akong camera. Nabali niyo siya. Wait. Let me stop my presentation first. Weird again eh. I'll turn off na lang my video. It appears nga kanang nabali akong ulo sa video. Something's wrong siguro with my connection, but yeah. So I hope you can see now the screen for our lesson this afternoon. Okay, so we need to understand the concepts first of coordinate systems and map projections. This will be used later when you decide which projection you will be using, so that you have an idea if how skewed your map will be if you layer it with a certain or different projection. This is essentially true for our case. In the Philippines, we've been using different coordinate systems, primarily because our old maps were hand-drawn, and when we need to update our maps using digitalized versions, we have difficulty how to place the shape of the Philippines in the whole location of the country. So we use coordinate systems to better understand how to place the country in a plane map. As we understood rather in our surveying subjects, the shape of the Earth is rather unclear and it's not perfect. So we used to represent it with a geoid object. But the problem with the geoid object is that you cannot place it in a flat plane. That is why projections are made to somehow represent your curved map or your very imperfect object from the Earth and place it in a very flat object through maps. So why do we need this? Aside from to place things into perspective, we also need this because GIS works with spatial data, and the data has numerical values. And when we want to put it into a location, such as a latitude or longitude, it needs to be precise and accurate. Third, globes are great for visualization, but they are not practical for many uses. So if you may have seen a globe, it's quite spherical, but in reality, it is not the shape of the Earth as how we see it from outer space. And the round Earth also, the model of the round Earth doesn't fit without distortion on a flat piece of paper. That is why projections are made to create a numerical conversion of your object and place it into a flat space. So we'll start first with coordinates. Now, coordinates are basically very basic for you. This has been discussed with your basic mathematics, that you can represent the points on a plane using the Cartesian coordinate plane. It just so happened that because we're looking at it at different perspectives, that we want to represent the space numerically and in different axes. So we started with an x-axis, and together with y-axis, you will see a two-dimensional model. However, because recording has advanced so great that we were able now to measure other variables and values, we came to represent things not just in 2D, but also in 3D. So the basic idea of Cartesian coordinate plane is to locate or get the data of a point and measure its distance from the two axes, namely the x and the y-axis. And as a review, we sometimes put numbers on it, like the distances across the x-axis and the y-axis. And together, this x and y gives us a location of that point. You may also further design or describe the point on which axis and coordinate area it belongs to. Or sometimes we call this as zones, like the first zone, like this one in the green portion, or the red portion, or in numerical definitions, we call it as quadrants. Okay? It's divided into 4 spaces. So the first quadrant, second, third, and fourth. So having said that, we can utilize this idea to place things in space. But the beauty lang with placing things on space is that you can create a very perfect definition of a Cartesian coordinate plane. Like the ray, it's flat. So it's a challenge now on how to place things that are not perfect into a very perfect definition, which is a Cartesian coordinate plane. We also use the rectangular coordinate system as reference. So if ma-recall lang nato, what does a rectangular coordinate system do, or how does it area calculations? We know for a fact that it's easier to solve for the area of an object if it's rectangular. So it's easier to multiply the x distance and the y distance, and then you will get the area. So rectangular coordinates are very usable in that application. However, you cannot find all points to be at an exact x, an exact y, and an exact p. That's why we utilize also other models. We have this model, which we call as your 3D model, using still the Cartesian coordinate plane. But this time, we want to define it using 3 variables. The first being the x coordinate, second being the y coordinate, and third, which is the z coordinate. This forms your 3-dimensional object, as you can define the distance along x, y, and z. This is very relevant in map projections because the location of space in reality, for example, if you have this point x, y, z, in reality, this is the distance. But when we want to present it in a map, we want to project the position of P towards D. So there is some numerical conversion going there, such as if you use the angle here and the angle of phi from the z-axis. So this is being utilized, but primarily because you're now using softwares, you can't see the process, or you can't really handle the process as manual as possible. Okay, automated naman siya for you. But in the olden times, say in the 1990s, when you need to map, you need to manually convert one point to its main projection point, which is from P to B. So sa inyo, swerte na kayo. You don't need to define all these things. Like if you have this Cartesian plane and you convert it into a spherical plane, that will be very tedious. Though there are calculators, but if you need to define points in a space, pag taga na kaayo, maglisod mo. So there are softwares designed to do that for you, which is in this case, we're using through GIS. Another idea behind this thing is that if you want to represent it as a globe, di ba? Meaning hemisphere, this is half of a sphere, munang hemisphere ang tawag ay half. The hemisphere is just one half of it. And if you notice, if you want to plot this point here and we want to locate the distance, you can either define it using the angle and also its radius. These things are collected by your satellites for you. So again, as mappers, we don't need to do it manually, but the theory behind it is that you can always put points around the sphere and they can be converted into flat maps. So whether it is along the x coordinate plane, y coordinate plane, or across the z coordinate plane. So this is an example of a sphere, a very perfect sphere, and we can name such locations in that sphere. We know, for example, that the zero meridian, the meridian is, by the way, the longitudinal lines. And the prime meridian is the zero line where everything is referred east and west. So if you belong towards the left, you are called part of the western meridian. And if you belong towards this right portion, then you belong to the eastern meridian. And these values are further defined later across their maximum values and also their signs. The equator is also another line to represent the location of the Earth. The equator has perpendicular lines across the longitude, so they always have a right angle here. And then all of these equators, especially the smaller ones, are called latitudes. So the equator is the longest latitude, and they can be further divided into the northern hemisphere and the southern hemisphere. The beauty lang with equators or latitude is that they have a unique maximum value compared to meridian. So I'll discuss later on saan ang maximum value. So if you need to define a location of something, you can either use the location of the line, such as this one, and further measure the distance, such as this one, that is the latitude distance, because it is along the equator or parallel to the equator. The longitude dione is the parallel line towards the prime meridian. So tanan din sila will define your location. So whether you choose a grid, a point, or a line, that is derived from the latitude and longitude values. So these are some of the values that you can use in representing latitude and longitude distances. And we usually measure it in degrees, minutes, seconds, or even decimal degrees. So as mentioned, this is your western section, eastern section, northern hemisphere, and also your southern hemisphere. So we can put the what do you call this land masses into your sphere and say that this is the nearest representation of the Earth if we somehow use the spherical projection. But take note that projections matter depending on which shape you want it to fit in. In this case, it's a sphere, but in some cases, you may use a cylinder or even a cone. So depende lang sa imong application. But later, you will notice that the spherical representation of the Earth is beneficial for the Philippines because we belong in the equator. But if you're in the northern hemisphere or southern hemisphere, then that would not be useful. So in a 3D coordinate system, this is again 3D because it has 3 dimensions, the X, Y, and Z. And it does not ignore the curvature of the Earth. That is why it's realistic or more realistic to use a 3D representation because it doesn't ignore the curvature of the Earth. So if you are trying to measure a very long line across a map, it's best to use 3-dimensional objects. But if you're using small points and there are only few, then you can use a 2D system. Now, this still uses latitude and longitude. However, there's a special value with 3D. It uses radius to specify locations. So such as this one, you can define the longitude, aka meridian, across the western and eastern section. So muna siyang reason nga nung ang latitude o longitude na sila value plus na sila sign nga 124 degrees north and 8 degrees east. So ang maximum value sa meridian is 180 positive east and negative 180 to the west. When it comes to latitude, it's always 90 ang maximum. It's positive 90 sa north and negative 90 going south. And the parallel lines define the distances of the latitudes. So, kung baka read mo latitude nga 91, sure naging kasayop na siya. E 90 na ang maximum. Kung gi-91 ka, nagilapas na ko sa pikas side, dili na siya pwede. Okay. The definition mong good is we need to cut or slice this open so part of your kanang angle is now divided. So dili nakakaabot sa piga side kinaputol naman. So 90 rin imong maximum. Kung gilapas kag 90 dito sa butana gituyok nakabalik sa imong first location. So as mentioned, these are how coordinates are defined. You can use degrees, minutes, and seconds, and also decimal degrees. Most computers use decimal degrees because they operate in a binary system. They like to use numbers rather than symbols. But in maps that are printed, mas beneficial ang degrees, minutes, o seconds. But then again, you have software, so you can work around with either DNS or a DD system. It's important that you know how to convert lang in this case. So I'll also teach you how you can do the conversion and use this for your mapping for your cartographic layouts. So one example of the usage of these values are in Google Earth. It's very dominant in that feature. Now you can really put places or represent places in a spherical projection, and the values are there. But take note lang that if you zoom out, the location of a certain place is quite skewed. So as you zoom in, matingala din mo either mo gamay sa ka-object or modako sa ka-object, depending on which angle you're looking at. Okay, nakadepende man sa imong projection. So we'll show it further here. This is a very old map. Until now, it's being utilized. This is a country boundary map. And you will notice some things. Why is it that in the middle, it's quite straight ang line? But as you go beyond the middle part, matingala mo, medyo mo curve lagi din ang line or the angle siya. So actually, that's the distortion created by the angle of which you're looking at the map. Most maps are designed that you are looking at it from the prime meridian. So objects that are near the prime meridian will appear as accurate as possible, ang ilang sizes. But those that are found away from the prime meridian, like this part, will appear bigger. So this is true for the x-axis. Madala mo nga, basta po ang Alaska compared sa, say, any country and Nigeria. If you compare the scale of those two countries, almost the same sila. But in this map, Nigeria appears smaller compared to Alaska. Or even, why is it that the Philippines here appears to be very small and thin, when in fact it is equivalent to one state of the United States of America? So, kaning section actually sa kanang Philippines, ang size nato is almost the same size to California, na isa rin siya ka-state sa US. So we are that powerful actually kung i-compare ang scales. Or in this map po, tingala ka, why is the Russian Federation so big? But the United States is smaller compared to Russia. Pero in reality, they're not. Okay? They're almost of the same size. Or Greenland, why is it too big? With Antarctica being too big. Again, this is because you're referring the scale from the middle. So everything that appears away from it are larger. So we use these representations to put markers along our soil and across boundaries of countries like this one. This is a picture of a person looking at a prime meridian line across Europe. So maklaro man ginato, balikan lang nato, ang prime meridian falls in these parts of France, going Algeria, etc. But it just so happened that the European countries were into tourism, so they said, okay, this will create some attraction if we place these markers on land. But actually, this line doesn't appear as straight as how it should be. Kaya dire, straight kaayo ang primary dyan, pag mag-plot na sa yuta, di man na mo straight, na may bukid, na may dagat. So again, this creates some false information. The errors of mapping, especially that we misrepresent some of our information when they're placed on maps. So further on 2D coordinate systems, we said that we can represent it into an axis. So we can define the location, and we say that if you're farther from the y-axis, you will appear larger, especially if this is taken from a curved object. And if you say represent it in a 3D object, you will notice also that objects that are farther from the origin will appear bigger, and this is because of the projection. Now, Cartesian coordinates ignore curvature of the Earth. Okay? Plane man sila, rectangular man sila. So they are ideal, Cartesian planes rather, are ideal for small areas. But if you want to represent bigger areas, like country or continents, kinahanglan na ka mo gamit dayon og 3D. So the common reference system for Cartesian coordinate plane is the Universal Transverse Mercator Coordinate System. We call this a CTM. And in the Philippines, we have a similar coordinate. We call this as the Philippine Reference System. So I'll also show you how this system will be used in mapping later on. So in map projections, the idea is kung na-kay curve na object, you want to place it in a plane map. So it's a systematic rendering of locations from curve to flat surfaces. So this is a basic example of how projections are made. So if you have a curved object or even a not so perfect curve, when it's placed in a flat surface, instead of appearing smaller, so you notice, mabinat siya towards the northern part or the upper part and also the lower part. So what will happen is, murag ma-stretch ang object pag naka sa taas. But if you are in the middle, so like sa ato, nasa equator, it's okay for us to use kanang coordinate systems na flat. But kung naka sa taas, di na magamit. So in that case, countries need to devise their own coordinate systems to fit their mapping needs. So naay mapping modeling using plane objects, cylindrical objects, conical objects, and there's also mathematical surfaces. So it differs from country to country and also the size. It just so happened that in the Philippines, a cylindrical type will work, but in some countries like nasa Russia, ay cone. Kung gusto ka dako imong land covering vast sections of the earth, so mathematical lang gamiton like sa China, it covers the northern hemisphere, but it runs from the Pacific Ocean padulong din siya sa Picaside and sa Silk Road. So medyo kailangan ka og dako-dako nga kanang services for that. So map projections, they actually alter the shapes of the object, the area, the distance, and also the orientation of an object in a map. And all maps contain error because there's a conversion from 3D to 2D, and the transformation may skew the size of that object. So rendering can be used using spherical surfaces, but it's not at all the time accurate. So you need to specify which coordinate you should use para ma-define yung tarong inyo. So as mentioned, there are four properties that you need or that can be changed by these projections. First is area. So it may appear big or small depending on the projection. Next is the shape. Some objects will appear rectangular or elongated if you use certain projections, or that the distance may appear longer as it should have been shorter, or even the direction can also change because of projection issues. So there are some notes on these properties like area and shape are mutually exclusive, while distance and direction cannot exist everywhere on map because of the skewness created by the conversion. So this conversion creates distortion. So objects will appear bigger or smaller. So just to demonstrate, this is the ideal projection that's being made. So if we say that this is the shape of the Earth and we want to place it in a map, so you see objects will appear bigger and illuminated if you belong in the northern hemisphere and also the southern hemisphere. But if you're in the middle, almost the same object. So this is actually the most common map used all over the world. We call this as the Mercator projection. So how did they build it? They used a simple shape, used a source of light, and they noted the angle created by the shadows from the light, and that created the projection. So makita nato nga from the spherical, gisulod nila og cylindrical, and the cylindrical, cut open na nila yung one side, paglatag nila, muna din yung isura sa mapa. Okay? The Mercator projection is advocated by European countries. Why? One way is because Europe appears bigger and it appears to be the center of the world, when in fact it is not the center. Okay? The other thing is Africa. Africa looks smaller compared to America and even South America. But in reality, Africa and South America is almost of the same size. Okay? So these are distortions made by the projection. And some countries would prefer to use this case because size matters in mapping. If you have a country that appears bigger, it means that you may have greater power. So Mercator projections were favored, especially by colonizers. Pag mag-adto na sila or mag-conquer na silang areas, kanilang dalon to say nga, we have covered this part and we have drawn it on the map. And your country is smaller than ours. Okay? Just like what happened to the Philippines when you were conquered by Spain. Spain is quite small in this map. Okay? But the Philippines appeared smaller budget compared to Spain, when in fact we are an archipelago of 7,954 islands, about 300,000 square kilometers. So you see, maps also create some distortions and gives us false information if it's not used on its appropriate usage. So further on the Mercator, it is a set of 60 zones across the world. So if you count this one, this is our 60 zones. And these values represent measurements in meters. Okay? So ideal siya, labi na kung SI ang imong unit, kay everything is in meters. Further, UTM is used for the global coordinate system, which divides it into zones. And this is common in studies, but take note, this is only used if you're covering large regions. And values are read as a longitude called easting and a latitude called northing. Okay, everything belongs outside of the equator, north or south, tawagin siya northing. Tapos anything that belongs left or right, the prime meridian will be read as easting, though na kay west. But kanilang ang normally gina-atag, so muna nga naka-value sa GPS coordinate na east o north. Okay. So this is the UTM zone map. So as mentioned, there are 60 zones, and if you notice, as ang Philippines, we belong to 51N. Okay? So nai-assign po nilang code dire. If you notice, XWV, UTSR, QPN. So nata sa N nga zone. Okay? And ideally, na mabuda sa Mindanao, muna gagamit ang UTM 51N. Okay? So magamit natin siya later for our large-scale maps. But take note, kung accurate ang imong surveys, magamit na sa Philippine reference system. Okay? So just take note of this one. So manipod siya ang polarized version, and this creates the issue now on the actual shape of the Earth. Okay? In the geodal model, equator or the equator rather is represented by a bulge. Kay gravitational man itong ilahang computation. So ang shape of the Earth is rather more like pressed sa kaning diri sa middle. So mas lapad da sa sides mo ng geodal bulge. But if atong i-compare ko na sa spherical na common object na gina-represent sa maps, using inabi dahil siya gamay nga error, like ang North Pole appears to be farther in the map, but in reality, it's just short. So, pati ang South Pole. So, pag magtanong mo sa Google Earth, matingala mo nga, ang object diri mas dako, whereas diri mas gamay. Pero pag imo lang i-try zoom, di ka na kang magamay din ang object. Depende man sa angulo ng asa ka nagtanong. So, may siyang other representation. If you use circles to represent the sizes of an object. So, in reality, pag tanaw niyo siya sa middle, muni ang size sa circle, but if you compare niyo kung nagtanaw sa object further north or south, it appears bigger. So, these distortions created by mapping. In the Philippines, we use 3 systems. First is WGS84. It's common to use this one. We also use this in our basic mapping tools. And the second one is Luzon 1911. It's quite outdated, but this is the reference for the maps that govern for the country to perhaps the city boundaries na ginagamit nato karon. So this survey was done in 1911, so that's why it's Luzon 1911. And further, this uses the Clark 1866 ellipsoid. So, dilita na mo pahagoon, kaniwan mo ta na computation ani pag-convert from Clark 1866 to Luzon 1911. So, I did this one when I studied in UP. Kaning Clark 1866 na ay conversion na buhaton nimo from the plane map, i-represent mo sa katong cylindrical. Then na program nga imo pang i-code para makakuha ka sa actual conversion ana. Kaya ang Clark 1866 was done in 1866, of course. So at that time they have vague ideas on the locations of some places. So kanang daan at mga mapa naka-format siya Clark 1866. Pero iman lang i-convert sa karon nga pamaagi, kailangan pa ka mag-convert from 1866 to 1911 nga version, then to 1992 nga version. So, wala ta na mo gihago anak apart. So currently, the Philippines uses PRS-92. This is the Philippine Reference System, datum of 1992. So, these observations were taken from Luzon 1911, and to show you the map of that, kani ang zones created from UTM compared to kanang PRS-92. So sa PRS-92, we have smaller zones, and the reference from zone 1 is kani zone 2, then to Luzon, zone 3, tapos zone 4 and zone 5. Now again, this creates some distortions. If you notice, mura man yung ugatan bitaw ka og lata. So ang lata, pag tanawan nila, they are further, so they will appear clear. So ang nahitabo, because we're looking at its middle, so munang dako tanawon ang Mindanao. Pero para makuha ni, kung dili ka magtanaw sa middle, para makuha ni mong shape sa Mindanao, you need to look at its zone 5. So musab na siya nga pag magmapa ta og Mindanao, we use PRS-92 zone 5. Okay? So just take note of this projections, but I'll warn you when you use them pag kanang accurate na surveys, kay dili man pwede nga zone 1 gamitan sa Mindanao, kay di mapunay ang zone. Dili po pwede UTM 49 ang gamiton, hindi man nato na zone. Kinamang kita sa kanio zone 51 north, pwede nga, dili ka munta na sa Pikas. So, we will use them for our projections, but for the rest of the hour, I would invite everyone to watch the video on projections by entitled Why All World Maps Are Wrong. So, just give me time to edit your e-learn classroom. So just wait in the Google Meet, and then I'll copy the contents to your section. Okay ra ba na siya?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so ako lang sang i-import. Then I'll also change some contents kay basig i-3 pa nimo. So this is for section B3. So you should see this in your e-learn now. Okay? So nana dire ang video material. This is a little bit explainer lang on what the topic is. The contents are here. Some of the reading materials are also here. The data for the exercise is here. So the data is shown before the exercise, pero ang exercise video nara sa bus kaning exercise. Okay? So, duha ka video inyong lantawan karon. Una, kani about projections para na may idea further kung say ma-create nga errors because of projections. Then second, kindly watch the video about the exercise. This will show you how you can convert maps and place it into the GIS software. If for example you are using old maps, so ang data nga gamitan din ani will come from the data section. Kaning is the NumRia topographic maps. Okay? Nakuha ba na siya?
Yes.
Opo, sir.
Okay.
Yes, sir.
Naapay pangutana?
Wala na, sir.
Hello? May pangutana? Wala.
So far, sir.
None so far?
None so far, sir.
Video is 35 minutes. But we also need to see yung sa ideal output na naman. So let me just share my whole screen. So you will try to apply what you learned about projections in this exercise. The exercise is basically called georeferencing in any GIS software. Georeferencing gitawag na. Dayon the principles are taken from spatial referencing. So kanang ako mag-discuss ka ganiha. Okay, so let's just wait for it to open now. Okay, so I'll try to open the previous exercise. So this is exercise number 6. So ang atong ibuhat for this exercise is to position our old maps. Kani siya. This is an example of an old map. This map was surveyed by the Philippine government back in the 1950s. So our goal here is to not just honor the old map, no, but put the map in the modern coordinate system. So you will explore this using the exercise material that I'll be sharing. So gamit ni siya o kanang two softwares. You need to cut the map using paint and then perform the necessary positioning of the corners. So you will need 4 corners for this one. So kung ipa-explain ko ninyo sa pinaka-simplest nga kanang summary sa unsa ang gabuhaton, mura mo og gapilo og tela. So butang ta lang ang tela ninyo is crumpled na sa middle aning akong object. So wala siya na plansya. So kinahanglan ninyo i-plansya ang material by pulling the garment or the cloth sa corner. So birahon mo siya dito sa taas, upper left, upper right, right, o lower left para mabutang din siya diri sa ato ang GIS software. So isa pa lang ni siya, but what you need to do is add around 16 kabuok 16 kabuok wait lang max. So these are the contents of the folder. Kailangan nyo i-form. So 16 ni siya kabuok. Ayaw lang i-mine ng dalipuga nga na double. Pwede na po nyo i-delete. 17 man mo appear dire pero 16 da ang gamiton. So you will need to cut each of these maps. So like this one. So kani nga mapa inyong i-cut. Kaya di man na ito kinahanglan ang uban na section ani niya. Kaning mga legends. Ang kinahanglan ito kaning nga object, kaning sulod. So kinahanglan nyo ni i-cut. So nana sa video unsa ang siya cut or crop. You may use paint or pwede po na gamitin yung crop na command direct. Pero di mo ta parihatanan o kanang software kay naiuban na daan nga or bag-ura ka yung operating system so dili nimo run nga software. So para uniform, I asked everyone to use paint. So murag inanay niyo buhaton. So isulod ninyo siya. I-crop. Pag ma-crop na dayon, kani siya i-save ninyo as a separate file. So na din mo yung makitaan na ang or himon din ang folder. So inaya lang din yung itsura na. Kani din siya, may i-load din yung sa GIS software. Then pag ma-load siya dito, kinahanglan nyo birahon ang corners. So ang yun yung gamiton nga numbers ana will be from the main map. So i-open na po ninyo itong previously lang ninyo i-crop na file. Kaya kinahanglan man nato ang 2D coordinate system. So kinahanglan ninyo i-take note ng numbers direct. Kani sa upper corner, kaning 1, 2, 4, 15, 8, 20. Kani po dahil sa upper right, 1, 2, 4, 30, 8, 20. Sa lower right, 8, 10, 1, 24, 30. Kung sa lower left nga 124, 15, 8, 10. So pag mabuhat din ninyo na, ideally, mabutang din siya ginunan. So pwede man nyo i-check kung natunong bagyod na siya. Like kani. Sa old map na ay river. So i-check na ito na by river sa actual. So naamang yung river. Though medyo na skewed lang siya gamay. But at least, butang na to siya as how it should appear in old maps. Now, the beauty of this one, okay, you can look back in history like this one. It seems that the river here has an oxbow. Anisha. This is very relevant in studying in creating dams. Okay. Kung ay oxbow dire, so i-design din mo ang flow sa imo ang dam using 2 flows. But in actual or as how it looks now, isa naman day ang river flow. So ang river di ay had a history of overflowing from the other side. So gagamitan na mo ni for flood analysis. Or kung mag-design sa daog tulay, like kani, na tulay diri sa iligan, tanaw na tuon sa historical nga shape ana from the maps. So it seems isa ra day ang tulay sa daan. So kani ang old na tulay. So makita na to siya from the 1950s map. Pero ang new bridge dito wala nag-exist kay delta pa rin na siya. So na ay sandbar. So there's a probability that because it's a sandbar, ligon ang soil. So you need to do interventions pag mag-analyze ka. Okay? Ay, wait, then you record. So, okay na sa tanan?
Yes, sir.
Okay. So, as mentioned, short-term na itong session karon, almost for an hour ito siya. So, we'll have to end by 2:30 exact.
Bago lang nag 2:30, sir.
Yeah, mag-end ako. Aning nalito ang numero direct. Tapos na yung corner. Pabantayin ninyo nga medyo baga ang line. That is actually half of a cross here. So, kung pili mo sa point, timingon din nyo nga musulod ani para di kayo siya mas cute. Dili kayo siya masibog towards left, right, or even gani mura siya ma-elongate. Mas yun yung matarong og position. Then also, take note of numbers kaya usahay malibat ta bitaw sa numbers. Instead nga 810 ato mo input 820 kay abay dali ba sa keyboard. Or ang 124 wala ni mo na-appeal og type ang 4 so 14 ra ang ay kanang 12 ra ang nabutang so mas skew din na siya. So again, it's a trial and error. Pero kung imong i-slow ang process, tarong ni pacing, double check nimo ang numbers ni input o ang location nimo, dili ra man ka masayop o dili ra pud siya ma-overstretch.
Sabdan, sir. Thank you.
Okay.
Sir, medyo hindi ko naintindihan, sir.
Now which part?
Dun sa crosshair. Crosshair. Dun sa corner.
Okay, wait lang.
No po, sir.
Napalasang i-move sa ako daan ng inyong kanang video material para makastart ng kaya ang ato ra bang basic na e-learn E3 pa ni nga recorded session ako sa i-edit. Share na lang ako daan ng screen. Actually, katong uban nga wala na yung question, pwede naman malakaw kayo para makastart tapos mo watch a video. So, okay, section 3.
Thank you, sir. Bye, sir.
Bye.
Thank you, sir.